Okay, so let us derive our equation of an ellipse. Okay, so I would derive the horizontal ellipse. Okay, so considering this horizontal ellipse, so let us remember our parts of this ellipse. Okay, so we have our vertex. Let us consider this as my negative vertex, wherein I will have my negative a and 0, and my positive vertex, which is, so I will have positive a and 0, and of course I have my co-vertex. I will call this as my CV, wherein this is a point my minor axis, wherein I have 0 positive b, and my negative CV, wherein I have 0 negative b. Now, take note that an ellipse is a locus at a point P that moves in shots the sum of its distances from two fixed points f1 and f2 is constant. So take note that our f1 and f2 are the focus of our ellipse. So let's say we have my focus 1 and I have my focus 2. But what is the values of my focus 1 and focus 2? So I have, of course, my C, right? Negative C0 and positive C0. Now, at any point in our ellipse, let's say at point P, or a point xy, you would notice that based on its definition, that the sum of this focus is always equal to constant. So therefore I may say that f1p, meaning the distance from f1 to p, plus f2p, meaning the distance from f2 to p, is equal to constant. Then based on my discussion a while ago, that constant is equal to 2a. What is our a? The distance from the center to our vertex. And also, our a is equal to the Pythagorean theorem, in which I have my c square plus b square, which is our a square, or the hypotenuse between the sum of my b square plus c square. Okay, that is our a. Now, Since I know that we already have f1 p1, f1 to the point p plus f to the point p is equal to 2a, therefore we can derive our formula knowing that we are considering our center hk at center 0 0. Okay. Okay, so from here, using my distance formula, I can derive my f1, which has a coordinate negative z0 to xy, which is equal to f1p is equal to square root of x minus negative c square plus y minus 0 square. Okay, just reminding you of the distance formula, d is equal to square root of x sub 2 minus x sub 1 square plus y sub 2 minus y sub 1 square. Okay, yan. So from that, I will have square root of x plus c square plus y square. That is my f1p. Next is my f2p. Okay, so my f2p is of course from my f2 to this point p. Okay, so my f2p is equal to square root of x minus positive c, so x minus c square plus y minus 0 square. So by further manipulation of the equation, I will have square root of x minus c square plus y square. By substituting the values that we have presented in our major equation, in which this equation or these equations, so therefore I will have square root of x plus c square plus y square plus f2p, which is equal to square root of x minus c square plus y square equals to a. Okay, the next thing to do, of course, is to further simplify this. Okay, so we would use our mathematical analysis. So we will have square root of x plus c square plus y square. I would transform this term the other side, so 2a minus square root of x minus c square plus y square. Next is I will square both sides, okay, in order to eradicate the square root. So from here I will have square root of x plus c square plus y square will be equal to x plus c square plus y square, which is equal to, of course, you would use our binomial theorem, right? Wherein we have a square, so it's negative, so 2ab plus b square. So from here I will have 4a square minus 2 multiplied by 2a multiplied by square root of x minus c square plus y square plus square root of x minus c square plus y square squared. From here, okay, we will have an equation equal to x square plus 2xc plus c square plus y square, which is equal to 4a square minus 4a multiplied by square root of x minus c square plus y square, plus of course we'll have x minus c square plus y square. Okay, we will eradicate the square root. From here we would notice that we can easily cancel out our y square, right? But wait, we can still evaluate this or expand this x minus c square. So therefore I will have x square plus 2xc plus c square, which is equal to 4 square minus 4a multiplied by square root of xc square plus y square plus x square minus 2xc plus c square. So we can further eradicate or eliminate our c square and our x square, and also we can transform or transpose some parts of the equation to the left or to the right. So I will transpose this equation to this part. So we'll have 4a, which will become positive square root of x minus c square plus y square equals over 4a square. Okay, this will remain here. We have 4a square, and I would transpose my 2xc, so we'll have negative 2xc minus 2xc. So for here I will have 4a multiplied by square root of x minus c square plus y square is equal to 4a square minus 4xc. What you notice, we have 4, in which we can factor out 4 to either of the equation, and then 4 divided by 4 is equal to 1, right? And also I will resimplify my equation, wherein I would divide a to the both sides of the equation. So we will have square root of x minus c square plus y square, which is equal to a square minus xc all over a. Okay, in order to get the value of our, or in order to prove our formula, I will square again both sides to eradicate for my square root. So from here I will have a value equal to x minus c square plus y square, which is equal to a to the fourth minus 2a square xc plus x square c square all over a square. Okay, and also in this equation I will have x square minus 2xc plus c square plus y square, so in which I will have a square, because a raised to 4 divided by a square is a square, minus 2a square xc divided by a square is 2xc plus x square c square all over a square. So notice that we can cancel out our xc. And also from this, we will group all variables that are similar and all constants. Take note that I will transpose my constant here, this side, and my variable to this side. So from here I will have x square minus, I will transpose that x square c square all over a square plus my y square is equal to a square, and I will transpose this c square, transpose this c square to the other side, so c square. So by further manipulation of the equation, I will have, or I will, factor out x square to this equation. So you have x square multiplied by, take note, if I will add x square to this term, so therefore I will have my a square as my least common denominator, LCD. Okay, so a squared divided by 1 multiplied by 1, so I will have a squared minus c squared plus my y square, which is equal to a square minus c square. If I would divide both sides by a square minus c square, you would notice that, okay, I will just write it here. So we will have x squared multiplied by a square minus c square all over a square divided by a square minus c square plus, of course, property of our fraction, y squared divided by a squared minus c square. So a squared divided by a squared minus c squared divided by a squared minus c squared is equal to 1. So you will see that a squared divided by a squared is equal to 1. So this will cancel out. So you'll have x squared all over a squared plus y squared divided by a squared minus c squared, which is equal to 1. Now, the best thing in deriving this equation is that you will familiarize yourself that since this is a value b and this is a value c, and from our calculations earlier, is that we can get it using this Pythagorean theorem, which is this value a, in which we may say that by Pythagorean, b square plus c square, okay, is equal to a square. Okay, take note of the variables that are used in our ellipses. Unlike the original Pythagoras, wherein we have a, b, c, but in this ellipse, our a is our hypotenuse and our b and c are the two adjacent length of our adjacent and our opposite in our equation. So therefore we'll have b square plus c square is equal to a square. Our main objective is to have this equation. So therefore we may say that our b square is equal to a square minus c square. Now, if we rethink of this and go back to our equation, you will see that a minus c square is seen in our equation or in our derivation. So therefore I will have x square all over a square plus y square all over b square equals 1. Okay, take note that my derivation is similar to the derivation of my vertical ellipse, but only is that, of course, if they have vertical ellipse, you will have, or you will change your foci, in which your foci will be parallel to your x-axis and perpendicular to your y-axis. But the process will be the same as long as you would add the 2 points, okay, wherein you would add the distance from the fixed point focus to a point P, okay, and then of course there are 2 focus in our ellipse. You would get their sum, and then this is equal to a constant, which is always equal to our 2a. Okay, so from this you will have this formula. Okay, so this is for our x or horizontal ellipse. If we consider h and k, therefore you would, or we would basically have a value hk, and this may lead to a confusion. Okay, but we can derive it actually. But since I would like, or I would just want to demonstrate the use of the different parts of the ellipse in deriving our equation, so therefore I have used my center 0, 0. Okay, considering that my h and k equal to 0. Okay,